physics question. Which of these two situations would make the balance go down? This is a classic online thing that you see all over the place. I'm going to explain it fully with physics. So over here we have a container of water with a ping pong ball, and the ping pong ball is attached to the bottom. So the ping pong ball is floating but completely submerged. You got to pull it down. Over here we have the same amount of water with a sphere that's made out of steel, same size as the ping pong ball, but the steel's lowered in, so it's held up here. So which way will it go? Well, the answer is that this one's going to go down more. So let's explain why. Over here, what force is pushing up my whole system? Well, my whole system has some mass, m, that's the combination of the water and the ping pong ball. Now, the ping pong ball is a lower density than water, so this is going to be less than just a full cup of water. So I'm going to call this, over here, let's just draw this as m1g, and then the normal force up. And that normal force is from the scale right there. Okay, so that's m1. And it's at rest, let's say. But we want to know, is it pushing up harder over here or over here? Now here we have to take this into two parts. Let's take this into two parts. First, I'm going to look at the sphere. The sphere has three forces acting on it. There's the downward gravitational force, MSG, there's the tension in the string, and there's also an upward buoyancy force, FB. Now that buoyancy force is equal to the weight of the water displaced. So it's, if you didn't have that sphere, you'd have the same thing. This buoyancy force is the water pushing on the sphere, so the sphere pushes down on the water with the same amount. So this is going to be a mass, looking at this whole thing, it's going to look like this. Is this too low? No. M2G N2, and this is going to be the same as the mass of the whole water. So here you have the water with the part missing, and here you have the whole water. So this side is going to be heavier, it's going to tilt down. Now, there's a bunch of variations of this. I'm going to actually make this experiment, I promise you. I'm not going to do it today, but I'll make this experiment and show you how it works. But that's the answer. The steel ball, even though it's being suspended, it still pushes down on the water, and that's the thing that most people get wrong. They think, well, the ball's being held, so it doesn't do anything. It does, because the water pushes up on it. The end, the answer, bye.